Okay, one more video for the video test solutions for test number 4. So here we have some shaded region determined by y equals tan x equals pi 4, and y equals 0. And we're asked to do this analytically to find the volume to revolve around the x-axis. Now in this case, our region is completely flush against our axis rotation, so there's going to be no gaps. That's disk method. Each cross-section is simply a disk. So we're using the disk method, which basically just the volume of a cylinder, right? Pi from A to B, r squared times x. Of course, r is to be terms of x, and the r is easy. Just that's x comma 0 for the center. That's x comma 2 tan x for the outer rim. So the erase is just simply 2 tan x. So now we're integrating this from 0 to pi over 4 of 2 tan x squared times dx. Very simple. That's all that's happened there. Very, very simple. Now, if you didn't know how to integrate that, you use your calculator, get 5 points. Okay, you lose 4 points, so okay, I don't know. But if you want to get 4 points, then here's what you do. So instead of using the calculator, but you can use the calculator on to confirm your answer. So let's square that. So it's 4 tan squared x. Now, if you do remember your identities, they're not that bad. The one that we tend to remember often, because it kind of just fits well with the unit circle and Pythagorean theorem, is that since we're looking for tan squared, what if I divide those by cosine squared? So, on the AP, this will hopefully help you to just remember this. So tan squared x plus 1 equals secant squared x. Or, of course, tan squared x equals secant squared x minus 1. So you can really seamlessly derive that in that manner. Substitute it in. So you have pi 0 to pi over 4. Then it's going to be 4 parentheses secant squared x minus 1. And you know what? I should just move that 4 out. Let's put it right there. So secant squared x minus 1 times dx. Now hopefully you remember that the derivative tangent is secant squared, so the answer to secant squared is tangent. So we're going back to tangent again. So 4 pi, and of course that's tangent x minus x from 0 to pi over 4. Continue working it out. So you're going to have tangent of pi over 4 minus pi over 4. And of course, you got to plug in 0. But tangent of 0 minus 0 is going to be 0, so we don't have to really worry about that. And tangent of pi over 4, we know it's 1. So your volume is simply 4 pi times 1 minus pi over 4. Or if you distribute, 4 pi minus pi squared. Now you can use your calculator to confirm this. You get a decimal, but then you can then plug in 4 pi minus pi squared to see if that decimal matches up. So let's turn it on. Alpha window, fn int, 0 to pi, ooh, that's wrong, pi over 4, and that was, put parentheses 2 tan x, another parentheses squared, so I'll make a 4 tangent dx. Kind of just wait a while, 0.858. So keeping our fingers crossed that this works out. Oh, okay, so I made a mistake somewhere. Where did I make? my mistake. Something seems a little... Oh, I forgot to multiply my integral by pi, right? Because it's a disk method. So if I simply divide that by pi, the previous answer, then we're okay. So so I know I did it right. Okay. Then the extra credit. Actually, extra credit went really well for you guys. Do a little separation here. dw over w equals k dx. Integrate the natural log outside of y. W, sorry, equals kx plus c. So w is going to be ekx plus c, which can be expressed in that manner. So that's just going to be a constant. That's just using our properties of exponents. So the most logical would be e then. It would be something times ekx. So it could be positive or negative, but anyway. So that's the bonus. Okay, so that concludes test number 4 solutions.